So to get started, we are just going to work on building the perfect square because today is called completing the square. And this is what we were just doing. I'm looking to make something squared. So what do I got? What's my factor that's going to add to be 6, multiply to be 9? X plus 3. And the next one? Minus 5. Okay. I want you to fill that out and focus on that last one. That last one's going to help us. What do we need to, at the end to make it true every time? So look for that pattern. Fill this out. Let's go.
Okay.
For this next one, add to get B. Multiply to get C, right? Okay, so this next one down, what would need to go there if my B term is negative 20? 100, right? So then, because negative 10 plus negative 10 times negative 10. So for the next one, if I use that, I got a 64. And that's a plus 8. Then I got a 49. Nope. No, I even got ahead of myself. Here's what I would do. A lot of kids got their calculators out and did like 3.5, didn't they? I like using 7 halves there. Here's why. What's 7 halves times 7 halves? 49 fourths. It just works nice. Right? So this one's 7 halves. You might have put 3.5. Out of curiosity, who put 3.5? Okay. Anybody put 7 halves? Do you see how the 7 halves plays nicer here?
Yeah.
Half of 7 is 7 halves. 7 divided by 2 literally means 7 halves. Okay. So that just plays nicer, especially to get that 49 fourths. Like 3.5 times 3.5 in your head ain't that nice, right? Okay, so for this last one, I like to go over here first. How am I getting that number every time? What am I doing with my B term? It's half of B. B divided by 2. And then over here to get C, I'm taking that number and doing what to it? I'm squaring it. Times itself, or squaring it, okay? So again, not so much today, but I already made the video for tomorrow because you have a sub. And I need to get that lesson in. You got a sub tomorrow, yep. So those fractions are going to play way nicer than the decimal when you can.
What's up?
So we're going to check out how to solve things that don't look like we can solve them. A new way. So what I'm going to point out here is, I'm actually going to get rid of May's. Sorry, May. Because it's the same thing, only different. And we're going to go off script with the directions a little bit. One thing I'm going to point out is, with your current set of skills, if you see this, you probably should rewrite it as this. Right? If we factored that currently, I can just look at that and know that my intercepts are negative 9 and negative 1. So you might be like, well, why are we learning this thing here that looks like way more work? Well, I like to liken it to like training wheels. We already know how to do this. We're going to approach one that we know how to use, and we're going to apply this new skill to an easier one before applying the new skill to something a little harder. Okay, so it's like training wheels is the reason why. I am also, instead of just watching all this, I'm going to take you step by step here. You should be doing this step by step in your math notebook. So Diego's looking at this, and we're looking at building a perfect square. And you saw this in the warm-up I gave you. If 10x is my B term, if I want a perfect square, what would I need there instead of 9? 25. So can I turn a 9 into a 25?
Yes.
Yeah, by adding 16 to it. And if I add 16 to both sides, mathematically, I'm all set, right? So everybody should have this written down. I'm adding 16 to both sides. So watch what I get now. X squared plus 10x plus 25 equals 16. And this looks like a problem we did last lesson now.
Wait, why'd you add?
You'll see.
Oh, I see.
I want it to be a perfect square because if this is a perfect square, look how I can rewrite it. X plus 5 squared is 16. Which means x plus 5 can equal what? It can equal 4 or negative 4. So above this line is new today, kind of. Below the line is what we did last class. Okay? And so that means that x equals negative 1 and negative 9. Let's check it out. Negative 1 plus 5 is 4 squared is 16. Negative 9 plus 5 is negative 4 squared is 16.
Wait, is this just a new way? Mr. Mac,
It's another tool in the tool belt, baby.
Mr. Mac, when you square it, you have to have the opposites. You can't have plus and plus, right?
Correct.
But you have 2 pluses. You have x plus 5.
No. X plus 5 is what's inside of here. My two answers are my 4 and negative 4 because if I square everything inside. Yeah. So just take a second, digest what we just did. Everything below the line we already did before. Above the line, we just made this function work to do that. Like, we're like, hey, function, you're not working to do this. We're going to make you work. Be like, I don't want to be square. And be like, that's it, you're square. And then you make it as perfect square. It's called completing the square.
So you just divide the factors form by...
What I did is I made it a perfect square by adding 16. I made that C term work. And as long as I do it to the other side, Asher, mathematically cool, legal. We're new to us today. I mean, it's not new stuff, but it's like a new thing that we're looking at, kind of. New to us today. So this is what this is called. I don't know how important, like usually I'm really into definitions. This one's not going to help you with much, but it is called completing the square, where we're going to manipulate the function to make it work, all right? And you know what I always say? The first time you see it, you should get it every time, otherwise... No, I don't always say that. That was just the first time. We got to look at some more together. So I'm going to get rid of Diego and May. Sorry, Diego and May. But we need to practice these problems. I'm going to roll through the first two with you, and then you're going to get after the next three. Just to go over again what we just did. I notice it's not a perfect square. I added 1 to both sides and said, yes, you are a perfect square. That means this x plus 3 can equal, because the square root of 1, 1, or negative 1, which gives me my two answers. These are, as Will said, the two places it crosses the x-axis. Two answers. And the reason there's two answers is because when you take the square root of something that's positive, you get two answers. Okay, so now we're going to look at, there's got to be a better way. Yep, I'm just going to do this. We're going to look at problem number 2. I'm going to get my space back. We're going to set up problem number 2. X squared plus 12x equals 13. So looking at this, I got that 12x. To make it a perfect square, what do I need to change about this?
Make it 144.
Make it 36.
I need a plus 36. Because if I'm getting 12x by adding two things, it has to be 6x plus 6x. So I need to add 36 to both sides. So now I'm messing with this function. And this function has a perfect square. X plus 6 squared equals 49. And here's what's great about this. That means that x plus 6 needs to equal 7. And x plus 6 also equals negative 7. Right? Because 7 squared is 49, and so is negative 7 squared. So x is 1 and negative 13. Again, I'm making it fit. I'm making it into a perfect square. You're going to be making it into a perfect square. It's like being like, hey, numbers, do what I want. But I'm saying that nicely, and it works. It's legal, okay? So you're going to try that on 3, 4, and 5 with your partner. Let's go. So let's look at number 3. Maybe this is easier just to paint over every time. Okay. Number trace. 0 equals x squared minus 10x plus 21. And I'm noticing if that b term's 10x, my c term needs to be what? 25, which means I'm going to add 4. I'm making you be perfect square function, okay? I'm making you. So now this is true, which means I can rewrite as x minus 5 squared. Multiplies to be c, adds to be b. And that means that x minus 5 can equal 2, and x minus 5 can equal negative 2. The most common wrong thing I see is right here. People write 4 and negative 4. But it's whatever this is squared. So square root of 4. Add 5, I got 7. Add 5, I got 3. That's a weird 5. Okay. There's my two answers. Everybody good on number 3? Okay, let's look at number 4 next. Okay, number 4. X squared minus 2x plus 3 equals 83. If this is half of that negative 2 is negative 1, what does c need to be then? 1. So we'll subtract 2. All right. And if I'm going to write it as a perfect square, x minus 1 squared. Multiplies to be 1, adds to be negative 2, check. So x minus 1 equals 9 and negative 9. So x is 10 and x is negative 8. Cool? Everybody seeing it? We're making it be that perfect square. Last one. It's going to take some reorganization, but it's still good. Okay. Who can tell me what they did first on 5? There's something that I did first.
I know.
Micah.
I did minus 14x.
Yeah, me too. Because I'm trying to get that b term on the same side.
And then,
So then, if this half of that's negative 7, right? Negative 7 plus negative 7.
49.
I need 49, so I'm going to add 9. So x squared minus 14x plus 49 is 9. I can rewrite that as x minus 7 squared equals 9. Yeah, well, it's good to stay organized because there's a lot of places to mess up, even though no one thing's crazy, right? Okay. So that means x minus 7 can equal 3, and x minus 7 can equal negative 3. So x is 10, and x is 4. Cool? I think it's cool. It's like, hey, you're not a perfect square. Psych! Now you are.
Whoa.
I think it's cool. Another thing I'd like to point out, I could get that in vertex form pretty easy. I'm just pointing that out for fun.
Wait, okay. I'll give you a vertex.
If you're minus 9 from both sides? Okay. Hey, this isn't equal to anything. I just want you to rewrite this as something that works to be a perfect square. Okay? It currently doesn't work to be a perfect square. I want you to rewrite to give me the perfect square. Show me to get your homework.